Hello children. So welcome to AIMS India's live class session. Today from physics subject, motion topic we are going to continue. So yesterday up to velocity we have learned, up to velocity topic we have learned. So today we are starting the topic of acceleration. So actually, so suppose a car is there. I want to create movement in the car. So I want to create movement in the car. So how can I create movement in the car? By applying force. How can I create movement in the car? By applying force, I can create movement in the car. So before applying force, the car is in rest position. The car is in rest position. So after applying force, the car will start moving. The car will start moving. So means before the velocity is zero, but after some time, what happens? Velocity will increase. It may become 5 meters per second or 10 meters per second, like that, based on the force what we have applied. Based on the force, its value will increase. 1 minute children, are you getting the video? So okay children. So when we apply force, the velocity of the car will increase. Velocity of the car will increase. So this increase of velocity is called acceleration. The increase of velocity is called acceleration. So to cause an object to change its velocity, here change in velocity is called to accelerate. So change in velocity is called to accelerate. To accelerate the vehicle, we have to apply the force. We have to apply the force. If we apply small force, there will be small acceleration. Suppose in the beginning velocity is 0. After some time, because we have applied a very small force, what happens to velocity? It may increase by very small amount to 2 meters per second. So as the force is small, the increase in velocity will be small. Here increase in velocity or change in velocity is called acceleration. So because of small force, acceleration will be small. Acceleration will be small. Okay. If we double the force, if we apply more force, so then what happens? The acceleration also will become double. The acceleration also will become double, because here acceleration means, so here what is the meaning of accelerate? What is the meaning of accelerate here? So accelerate means to change its velocity. How can we change velocity? By applying force. By applying force. If we apply force, if we apply small force, there will be small change in velocity or small acceleration. If we apply more force, there will be more acceleration. If we double the force, there will be double acceleration. If we triple the force, there will be triple acceleration. The symbol of acceleration is A. 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 How can we define acceleration? Acceleration means change in velocity by time. Change in velocity by time. So here, so acceleration, here acceleration of a body is defined as rate of change of its velocity. Sorry children, there is some small problem with the image. Okay. Acceleration means defined as rate of change of its velocity. So the symbol of acceleration, actually the symbol of acceleration is A. The symbol of acceleration is A. What is rate of change of velocity? Rate means, here rate means in how much time, how much velocity is changing. If we compare change of velocity with time, so then it is called as rate of change of velocity. So once again I am repeating children, here what we are doing, we are applying force. We are applying force. Because of force, what will happen? There will be change of car's velocity. There will be change of car's velocity. But how? It will happen in some time. That change of velocity will happen in some time. So change of velocity with respect to time, if we consider, then it is called as rate of change of velocity. Then it is called as rate of change of velocity. Here rate means related to time. Here rate means related to time. So change of velocity related to time. So the acceleration formula is change in velocity by time taken for change. So how much change happened? In how much time that change happened? That ratio is called acceleration. That ratio is called acceleration. Its symbol is small a. Its symbol is small a. So here, what is the change in velocity? Before applying force, let the velocity be u. U stands for initial, because in our name, in front of name, K Venkatesh, if we write the name K Venkatesh, what is K here? Initial. What is K here? Initial. Before the name, so before the name, we are having one letter here. This is called initial. In the same way, here U stands for initial velocity. Means before applying a force, the car, whatever velocity it is having, it is called initial velocity. After the force, velocity will change. Let it be V. Let it be V. V stands for final velocity. V stands for final velocity. Okay. Here, change in velocity means what we have to take? We have to take the difference of final velocity and initial velocity. That means final velocity minus initial velocity by time taken. Final minus initial means what we have in symbols, what we have to write? V minus U. V minus U. Time taken stands for T. Time taken stands for T. Okay. This is the formula for acceleration. This is the formula for acceleration. So here the SI unit of acceleration, already yesterday I have told what is SI unit? International System of Units, followed by all over the countries. Followed by all over the countries. Followed by all over the countries. So according to that system, the unit of acceleration is meters per second square. 1 minute. What is the unit? Meters per second square. Meters per second square. Because the velocity, the unit of velocity is meter per second, and the unit of time is again second. So what will happen? Meter per second per second. So in numerator part, by S is there, this will come down. This will come down. What happens? Meter per second into second. Meter per second into second, or else we can write meter per second square. Meter per second square. Or in words, we can write meters per second square. Okay. So when a body is moving with uniform velocity, when a body is moving with uniform velocity, means on straight road, one same car is moving. In the beginning, its velocity is 50 meter per second. 50 meter per second. It is traveling with the same velocity throughout its journey, without applying any brake or without applying any accelerator. With same speed, it is moving forward. So then we call it as a uniform. It is moving with uniform velocity. It is moving with uniform velocity. So here, as the velocity is same, velocity is not changing, we can tell that acceleration is zero. We can tell that acceleration is zero. Acceleration is zero. Okay, so many of them they are not able to understand because of image is not clear. So let me tell once again. So here, so now children, is it visible now? So actually here we have taken a vehicle. We have taken a vehicle which is at rest position. The vehicle is at rest position. So we want to make the vehicle move. We want to make the vehicle move. How can we make it move? We have to apply force. We have to apply force. So before applying force, how it is? it is in rest position, means its velocity is 0. Let us take it as u. Beginning velocity, let us take it as u. Its velocity is 0 meter per second. After applying force, what happens? Velocity will change. Velocity will change. This change of velocity is called to accelerate. Means the car is accelerating. The car is changing its velocity because of force. Because of that velocity, let it be v. Final velocity, let it be 10 meter per second. We have applied force and the velocity changes. Velocity changes. So we can tell that there happened some acceleration in the car. There happened some acceleration in the car. What is acceleration? Change of velocity. Why change of velocity happened? Because of the force. How much acceleration is there? Because we have applied very small force. So that's why there is small acceleration. If we double the force, then what happens? The acceleration also will become double. Here, change of velocity is 10. If we double the force, change of velocity will be 20. Change of velocity will be 20. Like that, small force, small acceleration, larger force, larger acceleration will happen. Okay, this is about acceleration. Next. So here, now I am making it small. So now, here, so acceleration means change of velocity. Change of velocity. How much change of velocity happened? In how much time? In how much time? Because the velocity will change. For changing of that velocity, it will take some time. So the change of velocity with respect to time, we call it as acceleration. Whenever we are using the word with respect to time, so then we have to call it as rate of change of velocity. What we have to call? Rate of change of velocity means with respect to time. With respect to time. So here acceleration means change in velocity. How much change happened? Time taken for change. That change happened in how much time? So this ratio is called acceleration. So here change in velocity means in the last it will have some velocity which is called final velocity. In the beginning it will have some velocity that is called initial velocity. That difference is called change in velocity. The difference is called change in velocity. Here change in velocity by time taken. It is called acceleration. It is called acceleration. So here the symbol of acceleration is A. The symbol of acceleration is A here. The symbol of acceleration is A. Final velocity symbol is V. Initial velocity symbol is U. Time taken is T. So the formula for acceleration is A equal to V minus U by T. Okay children? A equal to V minus U by T. The SI unit of acceleration is meters per second square. Meters per second square. Why? Because the formula is V minus U by T. The formula is V minus U by T, where V minus U stands for change of velocity. Change of velocity. Velocity units already we know. Meter per second. Time unit second. So what happens? We have meter per second is there. In numerator part, this S is there. It will come down. It will come down. So we can write it as meter per S into S. So meter per second square. So this is the unit of acceleration. This is the unit of acceleration. Suppose if the car is moving with same velocity, if the car is moving with same velocity, then what we can tell? It is moving with uniform velocity. What does uniform stands here? Same. Same means no change. Here acceleration means change, but uniform means no change. When the body is moving with uniform velocity, at that time there will be no acceleration. The acceleration will be 0. Okay. In what case acceleration will be 0? If the body is moving with same velocity or uniform velocity. Okay, children, we have taken so much time for acceleration. So let's go to next slide. Here. Next. So uniform acceleration. Uniform acceleration. Here, uniform acceleration. Because here acceleration is depending on velocity. Acceleration is depending on velocity. So here velocity is a vector. Velocity is a vector. So acceleration, it is also a vector. Already we have told yesterday, vector means which is having value and which is having magnitude and direction. Magnitude and direction. So what is uniform acceleration here? If a body travels in straight line, because acceleration is a vector, so we have to think that the body is moving in a straight line and its velocity increases, because acceleration means velocity should change. Velocity should change. Here velocity increases, but how? Equal amounts in equal intervals of time. Here body is moving in a straight line. Body is moving in a straight line. What happens to body? The velocity is increasing, but how? Equal amounts in equal amount of velocity increasing. In how much time? Equal intervals of time. Then we can say that the body is moving with uniform acceleration. Here acceleration means velocity changing. Velocity changing. But how? Equally. Equal amount of velocity changing in equal amount of time. Okay. If you observe the velocity time graph, here, suppose here 1 second. So this is a 0 second. This is 1 second. What is the velocity here? 10 meter per second. Next again, this is second. What is the velocity here? 20 meter per second. Again, this is third second. What is the velocity here? 30 meter per second. Like that, if we take points on this straight line, here we have x-axis, here we have y-axis. On the x-axis, time we have taken. On the y-axis, velocity we have taken. How is this straight line? What is the behavior of this straight line? In 1 second, velocity changes from 0 to 10 meter per second. In 1 second, velocity changes from 0 to 10 meter per second. Again, if we compare from first second to second second, not from 0. If it changes from 1 to 2, between these 2 seconds, what is the time interval? Again 1 second. Again in this 1 second, what happens to velocity? 10 to 20. Again 10 meter per second increased. Again 2 to 3. This 1 second, what happens to velocity? 20 to 30. Again 10 meter per second increased. Here time is changing, velocity changing. But how they are changing? Equal amount of time, equal amount of velocity changing. So this is called uniform acceleration. Here you should not get confused. Uniform means it does not change. Like that you should not tell, because here acceleration means what? Change of velocity. Velocity should change. Velocity compulsorily should change. But how? Equally. Equal amount in equal intervals of time. Then we call it as uniform acceleration. Okay. Any doubt regarding this? You can ask me through live chat. Any doubt regarding this? Somebody asking, sir, if it moves in straight line without any change in velocity, then what is called? If there is no change in velocity, acceleration 0. Siddheshwar Reddy, what we have to tell? If there is no change in velocity, so what? Acceleration means change of velocity. So acceleration is 0. What we have to tell? It is moving with uniform velocity, we have to tell. Okay. Next. Any doubt? Any doubt, ma? Okay. Somebody asking about online test. At the end of the session, I will tell you what is meant by velocity. Velocity means yesterday only we have discussed how much displacement changed in how much time. Okay. Okay, ma? This straight line is an example of uniform acceleration graph. Uniform acceleration graph. It's a velocity time graph. It's a velocity time graph. As it obeying this uniform acceleration conditions, we can tell that it is uniform acceleration graph. Keith Reddy, don't make personal chart. Okay. Next. Next about non-uniform acceleration. Non-uniform acceleration. What is non-uniform? In the name itself, you are having non-uniform means not same. Non-uniform means not same. But here acceleration is there, means velocity should increase. Velocity should increase. But how? In unequal amounts. In unequal amounts, velocity should increase. Here non-uniform means what? Velocity should increase, because here acceleration word they have given. Acceleration word they have given means velocity should increase. But how? Non-uniform also they have given. Non-uniform means unequal amounts in equal intervals of time. In equal intervals of time. Here time is equal, but increase of velocity is not equal. This is an example of non-uniform motion, acceleration. Okay. Suppose here, if you observe this graph, because as the body is moving in straight line, as the body is moving in curved line, here the body is moving in curved line. Here for 1 second velocity may be 5. For 1 second velocity may be 5. At 2 seconds velocity is 7. At 3 seconds velocity is 10. At 4 seconds velocity is 20. 4 seconds velocity or speed is 20. How is the change? In 1 second 5 meter per second increased. Again after 1 second 2 meter per second. Again after 1 second 3 meter per second. Again after 1 second 10 meter per second. Means this curved line not following any particular order. Not following any particular order. Means for equal intervals of time, the equal amount of velocity is not changing. Velocity is increasing unequally. So this speed time graph or velocity time graph, it's an example of non-uniform acceleration graph. Non-uniform acceleration graph. Okay. So it will be shown by a curved line. It will be shown by a curved line. It will be shown by a curved line. So next. So retardation. So retardation means deceleration. Retardation means we call it as deceleration or negative acceleration. Retardation means deceleration or negative acceleration. So here, if the velocity of a body increases, we call it as acceleration. It will be positive. Suppose if you apply brakes, what happens to the velocity of bike? It will decrease. That decrease of velocity we call negative acceleration. Decrease of velocity is called negative acceleration, or it is having some special names like retardation or deceleration. Like retardation or deceleration. Okay. Retardation means negative acceleration. Means decrease of velocity. Decrease of velocity. Retardation unit also same like acceleration. Actually, retardation also same like acceleration, or we can call it as minus A. We can call it as minus A. We can call it as minus A. Okay. We can call it as minus A. Okay, but tomorrow we are going to have exam, online exam. So these topics we can discuss later. Let's see some questions. Actually tomorrow morning from between 10 to 10:30, between 10 to 10:30, we are having a online live class regarding the online exam. So please watch the live class. Please watch that tomorrow morning's live class. So there we are going to tell where to write exam, how to write exam, all these things. Tomorrow morning 10 to 10:30 we are going to discuss. If you want to write the online exam, compulsorily you have to watch that session. And exam is postponed to day after tomorrow, Sunday. Because most of the schools and parents, they have requested to conduct on Sunday. So exam is postponed to Sunday. If you watch tomorrow live class already in YouTube, if you see the YouTube already in YouTube, 1 minute, let me show the video. In YouTube, already this live class is there. And already we have kept a reminder. Already we have kept a reminder here. Please attend 13/6/2020, means tomorrow live session 10 a.m. to 10:30 a.m. 10 a.m. to 10:30 a.m. regarding the online exam. Here we are going to discuss how to attempt AIMS online exam. How to attempt AIMS online exam. So students, please watch tomorrow's session so that you will get the clarity. Okay. So that you will get the clarity. Now, let's discuss some questions. Let's discuss some questions regarding the same. Okay. Here. So now, question number 1. So a particle, okay, a particle is traveling with a constant speed. A particle is traveling with a constant speed. What does this mean? Because for answering any exam, you have to understand the question first. Read the question thoroughly twice or thrice, so that you have to understand the concept first, then you can answer that question. Simply don't keep ABCD options, because we are going to have negative marks tomorrow. You are going to have negative marks for the questions. If you keep wrong answer, you are going to lose the marks. Each question carries 4 marks. Negative mark -1 will be there. If you write correct answer, 4 marks you will get. If you write wrong answer, -1 mark you will get. So that's why check out the question carefully. A particle is traveling with a constant speed. What is the meaning of constant? Same speed, uniform speed. Means speed is not changing. What does this mean? What does this mean? Option A. The position of the particle remains constant as time passes. What does it mean? Time is changing, but position of the body not changing. Next, the particle covers equal distances in equal time intervals. Equal distances in equal time intervals. That is second. Third option. Acceleration of the particle will be 0. Third option. Fourth option. Particle does not change its direction of motion. See, it's looking like very simple question, but it will make you confused. It will make you confused. What is the correct answer? Try to guess answer. Try to guess the answer. So many of you given B as the correct option. Why most of you given B? All of you given B only. Is it correct? Anybody? Somebody given B or C. So what is the correct answer, ma? Very good. So many of you keep it up. Because here constant speed means it is having speed. It is having speed means automatically its position will change. Its position will change. So this is wrong answer. What is constant speed? Equal distances, equal time intervals. That is correct answer. Here constant speed, because acceleration depends on velocity, not speed. So this is wrong. Here a particle does not change its direction, because speed never depends on direction, because speed is a scalar. This is also wrong. So B is the correct answer. Very good, children. Let's go to the next question. Question number 2. Read the question first. You have to read the question first. A particle shows a value of. Already I have told yesterday. What is the other name for value according to physics? Anybody? Anybody? Can you answer through live chat? What is the other name for value? Other name for value according to physics or according to physical quantities? What is the other name for value? Babu Rao. Very good, ma. Babu Rao, magnitude. Sheikh Asma, magnitude. Magnitude. So many of them given the answer magnitude. Very good, children. The magnitude, because already yesterday we have told product of numerical value and unit. Here the value of a particle is given like this: 46.0 meter s to the power of -1. Here meter second to the power of -1. We can also write it as meter per s to the power of -1 will come downside, s to the power of 1, or we can write meter per second, or we can write meter per second. What is meter? Meter stands for what? Meter stands for distance. Second stands for what? Time. Second stands for time. So what is d by t? Distance by time. What is distance by time? Ratio of distance by time. Let's see the options, ma. What is the first option? Force of the particle. Second option, velocity of the particle. Third option, acceleration of the particle. Fourth one, momentum of the particle. What is correct answer? Because in multiple choice questions, according to options, you have to give the answer. Somebody telling speed. Speed is also right answer. Speed is also right answer. Because distance by time means we can call it as speed. But in options, it is not there. So what is the alternate answer? What is the alternate answer? Hemalata is telling velocity. Hemalata, so Kirti Reddy told velocity. Zagan has told velocity. Okay, so many of them giving answer B option. Somebody telling A option. A option, C option. I think they are not following the content. Please children, listen carefully. Meter per second stands for distance by time. Here, distance by time means actual answer is speed. But in option, speed is not there. So, we can take it as velocity. Because velocity is a vector. Here, along with the magnitude, they have to give the direction. Sometimes, they may not give direction. But still, velocity will be the right answer. If it is given like a fill in the blank, then you have to keep speed as the correct answer. Speed as the correct answer. Okay. Here B is the correct option. Next. Question number 3. See, question is somewhat big. The positions means 2 positions, more positions. The positions of a particle moving along a straight line are x1 equal to 50 meter at 10:30 am. 10:30 am. And x2 equal to 55 meter at 10:35 am respectively. So, what is the displacement? What they are asking? Displacement means d bar. Displacement means d bar. Why we have kept bar here? Because displacement is a vector. It depends on direction. What is the displacement of the particle? 10:30 am to 10:35 am. What they have told? It is moving in a straight line. At 10:30, when the time is 10:30, where is it? It is at a place of x1. It is at a place of x1, which is equal to 50 meters. What about 10:35 time? At 10:35, it is at a position called x2, where that location is value is 55 meter. So here distance is marked as 50 meter. Here displacement is marked as 55 meter. What is there? What they are asking? Sorry, here position is marked as 50 meter. Here position 55 meter. Now what they are asking? Displacement. What is displacement? Change in final position and initial position. What is the change? 50 meter to 55 meter. What is the change? There is a change of 5 meter. There is a change of 5 meter in straight line. There is a change of 5 meter in straight line. So what is the answer? What is the answer, children? 5 meter is the correct answer. 5 meter is the correct answer. Somebody giving answer 5 meter per second. 5 meter per second. Suppose if you have another option, instead of 7 meter, if you have another option 5 meter per second, instead of 2 meter, if you have another option 5 meter per second square, they will give option like this to confuse you. Actually, they will give options like this to confuse you, because they are asked about displacement. What is the unit of displacement? Here 55 meter, 50 meter. What is the change? Meter. Displacement to be in meter, because meter per second means it is velocity. Here value is 5, but unit is not displacement. Unit belongs to velocity. Here value is 5, but unit belongs to acceleration. So that's why along with the number, correct unit also we have to tell. Correct unit also we have to tell. So B is the correct option. B is the correct option. So next. Okay. Next one, last question. A car covers 30 kilometer at uniform speed of 60 kilometer per hour. Means during the journey of 30 kilometer, this speed is not changing. 60 kilometer per hour speed. So first distance, let us take it as S1. What is the first distance? S1 is 30 kilometer. What is the first speed or distance? Take it as D. Distance, take it as D. D1 30 kilometer. What is the first speed? S1. How much? 60 kmph. 60 kmph. Next 30 kilometer means second distance is 30 kilometer. Second distance is 30 kilometer. What is second speed? Second speed how much? S2 how much? 40 kilometer per hour. 40 kmph. Now what they are asking? Total time. What is the total time taken? What we have to do? We have to take first time T1 and we have to find second time T2. We have to find T1 and T2. Then we will get the total time. What is the formula for speed? What is the formula for speed? S equal to distance by time. What is the formula for speed? Distance by time. But here what we have to find? We have to find time. So this T will go here, speed will come here. So speed equals to distance by, D stands for distance, S stands for speed in this case. So distance by speed. So here T1 equal to distance by speed, D1 by S1. D1 by S1. What is distance 1? 30 kilometer. What is speed? 60 kilometer per hour. After cancellation, what we will get? 1 by 2. 1 by 2. Half an hour. What we will get? Half an hour. 1 by 2 means because it is in hours. Because 31s are 30, 13s are 60. What we will get? 1 by 2 hours. 1 by 2 hours means half an hour. Half an hour means how many minutes? 30 minutes. Half an hour means how many minutes? 30 minutes. In the same way, what is T2? D2 by S2. Distance by speed. What is distance? 30. What is speed? 40. 0, 0, cancel. What is 3 by 4? They have given 3 by 4 hours. 3 by 4 hours. To change into minutes, we have to multiply with 60. We have to multiply with 60. 4 15s are 60. 3 15s are 45. What is the second time? 45 minutes. What is T2? Second time? 45 minutes. Now what is total time? 30 minutes plus 45 minutes. What is the total time? 75 minutes. What is the total time? 75 minutes. What is the total time? 75 minutes. Here options are here. What is the correct answer? What is the correct answer? 75 minutes is the correct answer. So sorry children, next we have 10th class. 10th live class is there. If you want to check the solution, you can watch the video once again. Extremely sorry. So tomorrow please attend the live class from 10:30 to 10 o'clock to 10:30. 10 o'clock to 10:30. So thank you for watching our video. Please subscribe on the channel and press the bell icon for receiving